So we're going to use the basic, some basic trig ratios, specifically the basic trig ratio of sine, to see if we can develop a law that will help us to solve for angles and sides and triangles that aren't 90 degrees. Now, of course, we know that sine of theta equals opposite over hypotenuse. But again, that only applies in a triangle with a right angle in it. Right? And we're pretty good at using SOHCAHTOA to solve triangles, find angles and sides in triangles that have right angles. But the one that I have here, this triangle here, is not necessarily a 90 degree or right angle triangle. It looks like it might have a 90 degree angle in it, but we're not too sure. So anyway, we're going to remember, first of all, that the convention for naming vertices and sides is that when the sides are named with capital, or not the sides, the vertices, when the vertices are named with capital letters, then we label the sides opposite them with the small version of those letters. So we have vertex or angle A, angle B, angle C, and we have side small a, side small b, and side small c. Now, this is going to, the sine law is going to be a law that we develop by starting here, by taking this triangle and saying, there's no 90 degree angle in it, so we're going to add another segment in here, and we're going to know that it's got a 90 degree angle. We're going to call it the height, or h. Since we now have, maybe we could describe this as being two triangles, right? You got this triangle here and this triangle here. So maybe now we have two 90 degree triangles. So what we're going to do is we're going to ask ourselves, what could we say is sine A? Well, sine A, sine theta, of course, equals opposite over hypotenuse, and the opposite side to angle A is, in this right 90 degree triangle, h. And of course, the hypotenuse being the hypotenuse must be c. So we would guess that, or we would write that sine of A equals h over c. And now maybe we'd look at the other triangle, this right angle triangle here, and we'd say, well, we have an open angle here, and so we might say, well, might talk about that and say that's sine C, and in that case, the opposite side to side C would be side H, and the hypotenuse would be A, so I guess this would be H over A. Now we've got two ratios that both involve sine, and we notice that they have something in common. They both have h, and this h happens to be the same h. It appears for two triangles, but it's the same length, same side. So just like we do with linear systems, when we have the same variable that means the same thing in two equations, we're going to, I think, substitute these things into each other. In the first relationship here, we have sine A equals h over c, and we can rearrange that to be h equals, I guess we'll multiply both sides by c, of course, and it will be c sine h. C sine A. The second equation can be just as easily rearranged. We will have h on that side, multiply both sides by a, and it will get a sine c. So we can move this out of the way a little bit, and we have this one equals h, this one equals h. Since they both equal h, they can equal each other, and that means that c sine A must equal a sine c. A little bit of rearranging is going to be done here to get this equation that we have into the form that it's usually seen. We're going to basically divide both sides by c, small c, and we're going to divide both sides by small a, Right, these C's will cancel out, this A and that A will cancel out, and we are left with what's known as the sine law. Sine A over A equals sine C over C. Now, we could repeat this whole process by putting, for example, an H in this triangle and saying, okay, well look, now we have two right angle triangles, this one and this one. I know I missed a little bit with where that 90 degree, that height should be, but if the height is there, then we would do the whole same process, and we'd be talking in this case about sine B and sine C, because those would be the two open angles. And this would eventually lead us to finding out that sine B over small b equals sine C over small c. Now, because that is so, we could actually repeat the process one more time, and we would come up with the fact that sine A over A also equals sine B over B. So really, all together, once we're done playing around with all of those, we find out that it is true that sine A over A equals sine B over B equals sine over C, the sine law.